Hello and welcome to another edition of Ask the Expert here at Telescience Museum in Cartersville, Georgia. I'm David Dundee, Director of Education, and thank you so much for joining us on our virtual exploration of science. Just wanted to tell you about some upcoming events here at the museum. Next Friday on June 23rd, we will have lessons from nature, gecko adhesion, the high power movement. We'll have an expert coming in, Dr. Crosby is a professor in material science and polymer science and engineering, and he is also the inventor of Gek tape, which is a non-sticky adhesive tape, and it's based on the biology of the feet of a gecko, and just amazing stuff like that we'll be talking about that night. The next week on June 28th, we have our Lunch and Learn series here at the museum, and 12:15 that afternoon of the 28th, we will be having a presentation on 3D printing, and we'll have Hiram Knickenbocker here showing off some of his 3D printers, and we'll have an interactive activity for our young scientists to make their own 3D objects that particular day. And then, as we move on into July, I want to let you know that the Wild About Weather Day is on July 15th. We'll have a whole festival of weather here at the museum. The Weather Channel will be here with some of their online on-air folks, and they'll bring some activities we can do. And their chief science editor will be here to talk about weather and predicting weather. And our old friend Glenn Burns from our local ABC affiliate, our chief meteorologist emeritus, will be here to talk about hurricanes and predicting violent weather. We'll have activities that day. You can take home your own home weather station, and we'll have a number of other activities that particular day. So please come out for Weather Day. And the following weekend, if you're into rockets, we will be having our Build and Blast workshop where you can come learn about rockets, build your own rocket, and our NASA ambassador will be here to talk about NASA rockets, and then you can launch your rocket and take your rocket home with you. So that sounds pretty cool to me. Anyway, today we have the honor of hosting Dr. David Rounce, and he's assistant professor in civil and environmental engineering department at Carnegie Mellon University. He received his bachelor's in civil engineering from Villanova University and his master's in environmental and water resources engineering and PhD from University of Texas. And he's done his postdoc up at the University of Alaska in Fairbanks. And I got wind of Dr. Rounce's research in an article in the Atlanta paper back in January about glaciers and the disappearance of glaciers. And today he is with us to talk about disappearance of glaciers and why we should care about it and how it affects our planet. So, Dr. Rounce, thank you so much for being with us today. And I can't wait to hear all about glaciers.
Yeah, thanks so much for having me here. And those other events sound fascinating. I wish I lived around the area so that I could join.
You're invited anytime.
Thank you. So today I'm going to share just some work that we've been doing that was recently published on the cover of Science just this past January. So very new results that are very exciting about how the glaciers are changing and how they can inform how we think about adaptation and mitigation strategies in the future. So glaciers are responding to climate change. Here's an example of the Rhone Glacier in Switzerland. It's a depiction from 1850 and a similar depiction in 2000. So you can see the loss of the glacier as well as the thinning of the glacier, the retreat of the glacier. Tidewater glaciers, these are glaciers that terminate into our oceans. So here's an example of John Muir Glacier in Alaska in the 1940s and the 2000s. You see the rapid amounts of retreat and also the thinning as well. And this is where I did my dissertation work on Imja Glacier in the Nepal Himalaya, right around Mount Everest. And here's an old photograph from 1955. And you can see a more recent photograph in 2007. You see that a glacial lake has formed, the glacier surface has lowered, so a lot of retreat. And this is really happening everywhere. So anywhere you look, whether it be in Greenland, in the Antarctic, in Africa, in the continental United States, in the Andes, in the Arctic, in Alaska, in the Nepal Himalayas, you see stories of how the glaciers are changing and predictions of when they might be gone or what's going to happen as these glaciers change. And one of the biggest things that we care about is how the hazards are going to change. And so one that receives a lot of attention because so many people live around our coasts is sea level rise. And so glaciers are one of the primary contributors to sea level rise, and so that receives a great deal of research. Glacier melt can also be really important for slope stabilities, especially in high mountain communities. Here's an example of climate change being linked to avalanches in Everest that at the time was one of the deadliest events in Mount Everest's history. Glaciers can be a really important source of fresh water for hydropower systems. They can also be important for irrigation for high mountain communities as well as downstream communities. And then as these glaciers retreat, they can be prone to form glacial lakes. And those glacial lakes can become flood hazards. So lots of different impacts that we can think about whether you live in the high mountains or whether you live in the coasts, the glaciers are likely going to impact your life in some way. And I do want to note that when I talk about glaciers today, I'm going to be talking about mountain glaciers and ice caps. So we typically separate the glaciers into three categories. We have our mountain glaciers and our ice caps, which represent about 1% of the total ice on our planet. We have the Greenland ice sheet and then the Antarctic ice sheet. And the Greenland and Antarctic ice sheets are just so much larger than all of our mountain glaciers and ice sheets that they really have experts of their own who model those processes. But what's really fascinating is that even though mountain glaciers only represent 1% of the total ice on our planet, they actually contribute an equal amount to the ice sheets, and in some cases more than the ice sheets, to sea level rise. And so even though they're small, we see that they have a very large contribution. And so it's really important for us to be able to understand how the glaciers are changing. And now when we think about present day glaciers, they're rapidly losing mass. We can measure this from satellite observations. And we typically think about how rapidly our glaciers are being lost in two different ways. We think about them in terms of an average thinning of the glaciers. So for example, we know that glaciers in high mountain Asia, on average, for example, they're thinning by about a foot per year, or 0.3 of a meter per year. But we can also think about it in terms of a sea level equivalent. So if you take all of the glaciers, all of their mass loss, and you spread that water over the ocean, how much would it raise the ocean by? And so current rates of glacier mass loss are on the order of about 0.9 of a millimeter of sea level per year. Now, since we're talking about glaciers, it's probably helpful to have a little bit of an understanding of a glacier itself. So when we discuss glaciers, we typically think about two different areas. There's the accumulation area and the ablation area. And what happens is in the accumulation area, it's at a higher elevation. And so you get colder air temperatures, which means you have less melting occurring. And it also means that you get more snowfall. And so over the course of the year, this area will gain mass. When you go to lower portions of the glacier, they're located at lower elevations. And so you have warmer temperatures there, which means that in response to those warmer temperatures, you're going to get more melt. you're also going to get less snowfall, and so you're going to be losing mass over the course of the year. And so you start to see this imbalance where you're gaining mass really high on the glacier and you're losing mass lower on the glacier. And so what happens is the glacier is like a slow-moving river. And so you actually have ice from the accumulation area that's going to flow into the ablation area over time. And so a healthy glacier is going to have that ice that's accumulated be able to replace the ice that is lost. Unfortunately, what happens and what we're seeing now is that we're losing more mass than we're gaining, and so these glaciers are retreating. So what we really are interested in understanding is how are glaciers responding to climate change? And to do this, we're going to use a physical model. So we're going to represent the reality of the glaciers, and then we're going to use different projections of what the climate will look like in the future in order to help us understand how the glaciers will respond. And so we use a model called the Python Glacier Evolution Model, or PyGEM, and we've also combined it with another model called the Open Global Glacier Model, or OGGM. And what we can do is we can represent that mass change on the glacier. We do that using PyGEM, so we can represent how much snowfall do we get, how much melt is occurring. And for tidewater glaciers, these glaciers can lose mass to the ocean, where you see those big calving events, and we refer to that as frontal ablation. And so we'll represent that process as well. Now, for our model, we obviously need some climate data. And so we use monthly temperature, air temperature data, and precipitation data to force our present day models. But then when we look into the futures, we want to see how are these glaciers going to respond for various climate change scenarios. And we do this for a variety of different scenarios. The primary scenarios that we're using now are called shared socioeconomic pathways, or SSPs. And we also have a lot of different model parameters, and so calibrating our model becomes very important, but I'm not going to talk about that today. Now, what's really exciting is that we've really entered an unprecedented era of being able to monitor glacier changes. And one of the most common methods that we use today to monitor how the glaciers are changing in response to climate is using digital elevation models. And what this means is that we can use satellites to be able to understand where the Earth is, where the surface, what elevation is the surface of the ice. And we can do that in 2000, and then we can do it again in 2015 or 2020. And by differencing those elevations, we can understand how the glacier is changing. And so that's what the figure on the right is showing, is that in the lowermost portions of the glacier, we're losing about 2 meters per year for this glacier. And higher up, it's either right around zero or slightly gaining some mass. And what's really exciting, and this was a paper that was published a couple of years ago in Nature, is that we can now do this for every single glacier globally. And so we can understand how the glaciers are changing for all 215,000 glaciers in the world. So there are tons of mountain glaciers and ice caps in the world. And what we can do is we can start to see, for example, in Alaska, Southeast Alaska is experiencing some of the highest rates of mass loss compared to other regions. And then in other areas, for example, in high mountain Asia, over the last 2 decades, there was something called the Karakoram anomaly, where it's an active area of research, but these glaciers, they actually were staying in a state of near equilibrium. So the amount of accumulation was more or less balancing the amount of ablation. And so we can start to see how these changes are occurring, and we can use these to calibrate our models. We also have a lot more observations and the ability to measure how much ice is lost into the oceans. So for these glaciers that flow into the ocean, we can actually model how much ice is being discharged into the ocean every single year. And so this is a study that was published just this past year that looked at those changes over time, and it estimated this for every single marine terminating glacier in the Arctic. So just for perspective, if you were to have gone back 5 or 10 years ago and tried to do this global glacier modeling, you likely would have relied on measurements from about 300 glaciers. And these are glaciers where people have gone out and they've measured the glacier, they've installed an ablation stake, and then they've gone and resurveyed it and seen how much ablation had occurred over the summer. And they would do something similar where they would dig a snow pit and they would see how much snowfall they got. But now with these satellite observations, we can really move from those 300 glaciers that had observations now to measuring all 215,000 glaciers. That's really, really exciting. And so where we're heading is, now that we have our model and we have the data that we can use to calibrate our model, we can project the changes in the global glacier mass. And so this figure that you're seeing here, the different colors are showing you different climate scenarios. And so the dark blue is showing you shared socioeconomic pathway 1-2.6, which is essentially equivalent to somewhere, if you had 1.5 degrees or 2 degrees of temperature warming compared to pre-industrial levels. So when you hear the Paris Agreement and they talk about 1.5 degree change and a 2-degree change, it's more or less right around this scenario. And we see that for that scenario, the glaciers are projected to lose about 27% of their mass by the end of the century relative to 2015. Now, when we go to higher scenarios, so for example, that dark red, this is where if we continue having more and more emissions, we can get temperature increases that are on the order of 4, and some climate models project upwards of 6 degrees of change. And so we see here that the glaciers will lose about 44% of their mass. So a huge difference in how much glacier mass loss is going to occur over the next century, depending on our emissions as a global society. Now, one of the things that we wanted to do with this study was we really wanted to transform those climate scenarios and shared socioeconomic pathways into temperature change scenarios, such that we could understand how the glaciers are changing for 1.5 degrees, 2 degrees, 3 degrees, and a 4-degree increase in the global mean temperature by the end of the century. And if we look at that, we see that just about 1/4 of the glacier mass could be lost to 40%, depending on the temperature change scenario. But what's really interesting is when we look at the number of glaciers that will be lost. Even if we were to limit the global mean temperature increase to 1.5 degrees, we would still lose approximately 50% of the glaciers by number. And if we are at a higher temperature change scenario of +4 degrees, we'll lose about 80% of the glaciers by number. And the reason for that difference is that more than 80% of the glaciers by number are really small. They're less than 1 square kilometer. So these are very, very small glaciers. And what happens is that even for a temperature increase of 1.5 degrees, which is still a considerable temperature increase, these glaciers really can't survive. They can't retreat to higher elevations. They can't find a new equilibrium. And so most of them will be lost completely. While when you get to larger glaciers, for example, glaciers that are greater than 100 square kilometer, there are a lot fewer of them, but they have the ability to retreat and find a new equilibrium in the future. That said, those small glaciers, they can be really important for other reasons. They can be important for their water availability. They can be important for tourism. They can have cultural stories attached to them. And so even the loss of these small glaciers can have a big impact on local communities as well. Now, when we think about all those different regions that I showed you on the map earlier, what we find is that the different regions will respond to the temperature increases in different ways. So, for example, if we look at a lot of the areas, the regions that are located in the mid-latitudes, so not in the Arctic, in the polar regions, but more about where we live today, so places like in Central Europe or New Zealand, what we find is that these regions are really sensitive to differences between the +1.5 degree temperature changes to the +4 degree temperature changes. And really, between the plus 1.5 degree and 4 degree, we have the ability to go from saving a lot of the glaciers to losing the glaciers entirely in that region. So we have the ability to prevent widespread deglaciation in these regions. While if we look in other regions, for example, in the Antarctic and the subantarctic, we see a very linear relationship between the temperature increase and the glacier mass loss. And that linear relationship is very true if you think about the global scale of the glaciers as well. Now, as I mentioned, we now have this really unprecedented amount of data that we can use to calibrate our models. And what that means is we have a really complete and detailed picture of how the present day glaciers are changing. And we can start to look at those temperature change scenarios and think about how they're changing in the future. So the figure that you're seeing here, it's the mass at 2100 that's remaining relative to the mass at 2015. And so the red colors, the dark red colors, these are showing you areas where most of the glaciers in that region are going to be lost. On the order of 80 to 90 to 100% of those glaciers will be lost. When you get to the bluer colors, so for example, in the Arctic and the subantarctic, or here in high mountain Asia, you're seeing losses that are more on the order of a few percent, 10%, 20%. So there will still be a lot of mass remaining there over the century. And when you see these white circles that are outlined in black, those are showing you places that are going to be completely deglaciated in the future. So all the ice in those regions is going to be lost. So let's look at this. Here's 1.5 degrees. Here's 2 degrees, 3 degrees, and 4 degrees. You can see for 4 degrees that we have a lot more mass loss, right? We have a lot more dark red colors. The blues are shifting to the yellows and red colors. We also see that if you look at the areas that are losing their glaciers completely, those white circles are starting to become more and more prevalent. And so for 3 degrees and 4 degrees, there's going to be widespread areas that are going to be completely lost, which means we have the ability to prevent that. And that's really important to think about, right? If we're able to mitigate the temperature change, if we're able to reduce our emissions as a society, we can preserve glaciers in many of those regions. Now, one of the things that we discussed was that glaciers are really important for sea level rise. And so what we estimate is that glaciers globally over the course of 2015 to the end of the century in 2100 will contribute about 90 millimeters to 150 millimeters, depending on that temperature change scenario. And what this means is that the glaciers themselves will contribute about 3.5 inches to 6 inches in the future. Now, 3.5 to 6 inches might not sound like a lot, but what's really important to recognize is that glaciers are just one important contributor to this system, right? So glaciers are contributing about 20 to 25% of the global mean sea level, which means you can take that 3 to 6 inches and multiply it by 4 or 5, and that's what the projection for the global mean sea level would be in the future. You have to really incorporate other models, but it can give you a very rough estimate just to get a quick sense of this. What's also really important to understand is that when we think about the global mean sea level rise, we're really talking about the baseline. When we think about the impacts of sea level rise, we typically think about more extreme sea level events. So what happens when you have tides that are causing more flooding to occur, something that's called nuisance flooding? Or what happens when you have a storm system coming through and it causes a surge, so a bigger increase in the local sea level? Or even worse, what happens when you have a hurricane and so you have a really big storm surge that's occurring? And so these extreme sea levels are just going to be exacerbated when you increase that mean global sea level. And the impacts of sea level rise, they really vary. You can start to see that you can lose land, you can lose ecosystems, they can cause damage to individuals, they can cause damage to buildings, to roads, to our energy systems, and they can also cause damage to different human activities as well. And so when we think about the sea level rise, we hope that we can take action as a global society and mitigate a lot of those impacts, but we're also going to have to think about adaptation. And so for sea level rise, there's a variety of things that we can do, right? So we typically think about if we do nothing, what's going to happen, such that we can compare the benefits when we actually do take action to that do nothing scenario. And so one example that we can do is we can protect ourselves, right? We can build a seawall, for example, and that can protect the infrastructure behind it. Another common solution, especially in more rural areas where you have more gently sloped land, is you can accommodate. So you can actually lift buildings up such that they can reside on stilts, and the sea level can rise and the buildings will be safe from that sea level rise. You can also advance, you can move your home and retreat, or you can also explore one exciting area of research is our ecosystem-based adaptation strategies. So for example, what happens if we build more wetlands, or what happens if we change the upstream dynamics such that we have more sediment flowing to the coast such that it can replenish the sediments that are being lost. Now, what's really important to recognize is that the adaptation strategies that are available to people are really going to vary depending on where you are and the type of community that you're in. So when we think about this figure here was taken from a special report that was done by the IPCC back in 2019. And what you're seeing here is how different mean sea level rise scenarios for different RCP scenarios will affect risk. And so you see that all the communities are going to be impacted to some extent. So they're going to have moderate impacts to very high impacts, shown by those yellows to those purple colors. But that it's different between the mega cities and the islands, as well as the Arctic communities. And so when we think about these mega cities, right, so we think about New York City, for example, right, there's a lot of economic activity, there's a lot of people living there. That means there's a lot of money and resources to support adaptation strategies. And so a lot of adaptation strategies can be implemented, and they can reduce the risk of the future sea level rise. But when we think about Arctic communities or island communities, they're much smaller, they have less financial resources. And what we also find is that the adaptation strategies, they're just in an area where they're more at risk, right? They have those purple colors. And even taking adaptation strategies is going to, they're still going to have some amount of risk. And what that means is that these places, mitigation is incredibly important, but they're definitely going to have to think about adaptation even further. And one of the ways that our research group is trying to support this is by developing a new dynamic adaptive pathway tool. And what this tool is trying to do is really think about how we can use our money and our resources in a very effective way, such that we can plan for our present day changes. So the sea level rise that we experience today or expect to experience in the next couple of decades, we can plan and start to implement adaptation strategies to combat those. But then we can build additional strategies that maybe in 30 or 50 years we can implement when we have more information as to which climate scenario we're going on, right? How did we change our emissions as a global community? And are we on a path towards 1.5 degrees to 2 degrees to 3 degrees to 4 degrees? That's ultimately going to affect the adaptation strategies that are required in the future. And so we can use our projections and we can start to think about the timing until we get to a certain amount of sea level. So for example, if we build a sea wall that is going to protect us from 0.5 meter of sea level rise, we can start to project, okay, when can we expect that sea level wall to fail such that we need additional adaptation strategies to be considered. So this is something that our research group is actively working on. And before I move on, I do want to highlight that climate change mitigation is an equity and justice issue. And the same with climate change adaptation. It's an equity and social justice issue. So what we find is that many of the most vulnerable communities located in poorer, more rural areas, they're more exposed to the impacts of sea level rise, and mitigation might actually be their only option. And so it's really important that when we think about adapting and mitigating the impacts of climate change, that we also think about the communities that are going to be impacted and allocate resources accordingly to account for those differences. Now, glaciers are also the world's water towers. And so glaciers are a natural reservoir because they get all this snowfall over the winter, and then over the summer, they melt and they provide a lot of meltwater for downstream communities. And what I really love about this photo is that when we look at the glaciers in high mountain Asia and the areas that are downstream of it, there are more people that live inside of that circle than outside of it. And so I'm going to show some examples of high mountain Asia because there are just so many people that rely on glacier runoff from high mountain Asia. And what do we expect will happen to the glacier runoff as the glaciers change? Well, when we look at really long time scales, so on annual and decadal time scales, our glaciers are like a natural reservoir. And what happens is, as we start to melt the glaciers more and more, it's like you're opening the floodgates on the reservoir. So you're releasing a lot more water that's been stored. So you actually expect to have a peak in water. So you have more water available in the future. But over time, you've opened up your reservoir, you've released a lot of water, and eventually you can't release any more water. It's gone. And so what that happens is it causes a drop in the amount of water that is available. And the same thing happens on seasonal timescales. And seasonal timescales can be really important for things like droughts. And so this glacier runoff can be really important, especially in the end of summer in a lot of areas. And so what we find is during that peak water, when you've really opened up those floodgates and releasing more water, you also get more water in the end of the summer. But when you don't, when you lose those glaciers and you've emptied your reservoir, that drought protection that is given to you in the end of the summer by your glaciers is gone. And that can be really challenging to adapt to. So here, when we talk about glaciers in high mountain Asia, we're talking about some of the big river systems in the world, the Indus, the Ganges, the Brahmaputra, for example. And what we find is that the timing and the magnitude of peak water, it really varies depending on where you are, depending on how much ice is in that system, depending how the climate is going to change in the future, because there are localized impacts of climate change as well. And so here, just to highlight two examples, we see that in the Indus River Basin, we can expect the glaciers to contribute more runoff over the next century, such that this peak water really occurs sometime between 2050 and 2070. And that's a good thing, right? They'll have potentially more water, fresh water available, and so they'll still have that drought buffering capacity. While if we look at the Brahmaputra, for example, what we find is that the glaciers have already hit that peak water mark. And so what that means is that in the future, there's going to be less glacier runoff available. And so communities who rely on this runoff are going to have to adapt. That might mean that they need to conserve water, or it might mean that they need to take water from other places. So for example, they might withdraw more groundwater, which can have problems of its own. Now, the complete story, when we think about glacier runoff, requires a hydrological model, right? So we take our glacier runoff and we feed it through what's called the water balance model. It's done by some of my colleagues at the University of New Hampshire. And we can track how the glacier is going to move through the physical and the human systems downstream. So what happens when you encounter a reservoir and you take water from that reservoir and you spread it out over your fields, agricultural fields, and then it percolates into the groundwater system and comes back, and eventually it reaches the ocean. What's really exciting is that with this model, we can actually track what happens to that glacier meltwater. And so we can see that we can provide the model with glacier runoff. We can then look at how that glacier runoff is moving downstream. And so you can do this for every single river basin. And then you can look at how is that glacier runoff being used. For example, how much of that runoff, how much is the glacier runoff contributing to irrigation every single year? And we can do this anywhere, right? So we can look at peak water in Europe. So many of the European Alps, a lot of these glacier systems are an important freshwater resource. We see that we're passing or have already passed peak water in Europe, and so there's going to be less water available in the future. We find similar trends in South America, where we're already at peak water and are now seeing reductions or projecting reductions in runoff in the future. Now, I mentioned glacial lakes before. As these glaciers retreat, they can be really prone to form glacial lakes over time. Here's an example of Khumbu Glacier in the Nepal Himalaya. So this is the glacier where individuals who are climbing Mount Everest, this is one of the major base camps that is set up. And so what might happen is that over time, a glacial lake might develop at the bottom of Khumbu Glacier here. And now, if this water that is stored is suddenly released, we call that a glacier outburst flood. And when I was doing research, I actually trekking down to a community to talk with them about our research when a glacier outburst flood occurred in 2016 in the Nepal Himalayas. So here's an example of the type of destruction that can occur when some of these outburst floods occur.
So the glaciers, obviously they're changing because of temperature. Curious, one question came in from our audience is whether or not what impact glacier movement had. Our questioner said that she had watched a documentary about glaciers that they're actually moving. Is the movement new because of changes that are happening now, or is the movement of glaciers been accelerated by the change in global temperatures?
Yeah, that's a great question, and thanks for that question. What actually happens is that the glaciers have always been moving, right? So because you're gaining ice in that accumulation area and you're losing ice lower down on the glacier, there's always the movement of the glaciers. What they find is that now that you have more runoff in the system, that you're melting the glaciers more, it can potentially lubricate the bottom of the glaciers such that the glaciers can lose more and more mass in some cases. In other cases, you have the glacier retreating and the glaciers are thinning, and so we actually see a reduction in the movement of the glaciers, such that they're slowing down, in other words. But yeah, great question.
So it seems that, just to talk a little bit about what you've been talking about, the data, the glaciers themselves, the change in the glaciers, the disappearance of glaciers, really the key impact on the average human being is looking at water and food, whether or not it's sea rise that affects the aquifers, or it's a change in where you're able to grow food because of the access to water for your farmland. So it really is. It's interesting because those maps that showed the changes, especially in Asia, how that will affect the future of global migration of people.
Yeah, the fresh water that's available is really, really important. And in a lot of areas, especially in high mountain Asia, it does provide a lot of irrigation water. And that can definitely have a big impact on food moving forward, for sure. I don't want to downplay the sea level rise either, because even people who don't live on the coast, right? If we think about the United States, when we have these disasters that happen from hurricanes, for example, right, the federal government will fund efforts, recovery efforts. And so, uh, in a way, we're all paying for the consequences associated with climate change, whether it be wildfires, sea level rise, or anything else. Yeah. But the glacier's contributions to sea level rise, their fresh water, those are really two of the biggest impacts that people will experience. Which is potentially a good segue. I have just a couple more slides, but glaciers, they support a lot of socioeconomic activities around the world. They're really beautiful places. I feel incredibly fortunate to be able to call glacier fieldwork my office from time to time. And what happens is that here's an example of a glacier in Glacier Bay National Park. And cruise ships commonly go up in southeastern Alaska, and they go into these fjords and they want to see those calving glaciers and really experience how large these glaciers are.
But it looks like a toy boat.
Exactly. Yeah. The glaciers are huge. And what's really interesting is that for glaciers in Alaska, we can project how they're going to retreat. And what we find is that almost all of the glaciers, the marine terminating glaciers in Alaska, they're going to retreat out of the ocean and onto land. And so to have that ability to go on a cruise or to go by foot and see these glaciers is going to be greatly diminished in the future. And the same is true for really a lot of different Alaska glaciers in Alaska's national parks. This is also true in Europe. So here's some work that was done by colleagues showing what happens if there's no climate change mitigation and a +5 degree change in the future versus a +1 to 2 degree. And you can see that the temperature change, either way, the glaciers are going to retreat a lot. But the difference by this end of the century is huge. And the same is true whether it's going for tourism, whether it's for water resources. I mentioned Mount Everest. So Everest Base Camp is typically set up right around here, right? You have the Khumbu Icefall. We estimate that the glaciers are actually going to retreat for those higher temperature change scenarios. The Khumbu Icefall is going to retreat above that area such that it would no longer be glaciated. So some of these iconic peaks and iconic treks in the mountaineering community, they'll be altered because of the glacier changes. And the last impact that I want to share is a story of a glacier in New Zealand. It's called Ka Roi Mate Hinehuketere. And that's the original Maori name for what is now commonly called Franz Josef Glacier. And if you translate the Maori name, it means the tears of the avalanche maiden. And it's based off of a Maori legend that describes how Hinehuketere, she took her lover Tuave into the mountains, but Tuave couldn't keep up with her. And so Tuave ended up falling and an avalanche swept him away to his death. And Hinehuketere, she cried and she cried, and her grief was so pronounced that the gods froze her tears as a perpetual memorial to her sorrow and her regret. And so here you can see a picture of what Ka Roi Mata Hinehuketere looked like back in 1870, and you can see it more in present day, right? So you can't see this glacier unless you hike further up Glacier, and then you can start to get a glimpse. And we can see that depending on the future climate projection, this glacier could experience an additional 20% mass loss, or it could lose upwards of 85% of its mass. And so the key point here is that these glaciers, they're not just an important freshwater resource or important contributor to sea level rise, but there's also a lot of culture, a lot of spirituality that's behind these glaciers as well, especially for local communities. And one Maori individual named Naalisa Tumahe, she said, it's more than just a physical loss, it's a spiritual depletion, a depletion of our ancestral heritage and a devaluation of our past.
Wow.
And so I'll leave you with one closing thought, and that's really that these glaciers are telling us a story. Quite literally, there are glaciers that are embedded in oral traditions for those who have lived by the glaciers for centuries, but they also tell us a story of change. And so whether it be at a national park, at a World Heritage Site, or a mountain range, they really can share with us their beauty and their majesty, but they can also share a story of loss and the impacts. And they tell us a really clear story about climate change and the impacts to sea level rise and water resources and economies and cultures. And so it's really important to keep in mind that we as a society have the ability to impact what the future of these glaciers will look like by reducing our greenhouse gas emissions. And so the real question is, what kind of future story do you want to share? Thanks for having me, and I'd be happy to
Yeah.
any questions.
Yeah. So, I mean, looking at what you've just talked about, and you're talking about the loss of 83% of the world's glaciers by the end of the century, talking about the release into the ocean of something like 48 trillion metric tons of ice melting, and a sea level rise of 4.5 inches, and maybe even worse. I guess one of the predictions in one of the slides that went by said as much as 6.5 inches in the worst case scenario. So amidst all of these gloomy predictions, what can an individual do? I mean, what can be done, and is it too late? I mean, is it just we've waited too long, and the process of climate change is in the process? What can be done?
Yeah, that's a great question. And it's a mixture of both, right? So it's important for us to understand that, the glaciers, a certain amount of glacier mass loss is inevitable, and that's going to happen. But what we found is also that every increase in temperature really matters. So there's a big difference between 1.5 degrees increase in global mean temperature versus 3 to 4 degrees. And so what that means is that the best way that we can take action, and really what I have hope for, is that we have the ability to actually reduce a lot of those impacts, to preserve our glaciers if we can take action. And the biggest action that you can really take is to be a member of our global society and to support efforts that appreciate the environment, that value the environment, that seek to reduce those greenhouse gas emissions in order to mitigate a lot of the potential impacts moving forward. Which is, on an individual level, right? It's to be scientifically literate and to really share your knowledge with others around you.
So several questions coming in from our audience. So let me just go back to the early one. So in your images from New Zealand, it looks like the glacier is being lost from the bottom up, and the peaks appear to be consistent in being covered. Is that correct, and why?
That is correct. Yeah, and it's a very good observation. The reason being is that the lower areas where you see a lot of the glacier retreat, those are warmer, right? So as the glacier changes and responds to climate change, you have more melt that's occurring there, and you simply just don't have enough flux of ice that comes from the accumulation area to replace that amount of ice that's lost. And so the glaciers retreat further and further to higher elevations, really in search of a cooler climate or a cooler area where they can hopefully find some stability.
And why is it seem that Alaska is losing glaciers faster than other places?
Yeah, it's a great question. And really what happens is the increase in temperature is not uniform around the world. So when we talk about a 1.5 degree increase in global mean temperatures, there are actually some regions that will experience a 3 or 4 degree increase in temperature, while other regions might experience no temperature increase, right? It's just an average. And so um, those really local changes can have a big impact on what's going to happen in the future. So Alaska is one of the areas where you have the Arctic amplification, which means that temperatures in the Arctic regions will be warmer uh, than the global mean temperature. And so that's one of the reasons that you're seeing a higher rate of mass loss in those regions compared to other regions. It's a
Uh,
great observation.
yeah. Um, so I know most of the research is focused on how to lessen the loss. Is there any research being done on how we could potentially replace or increase glaciers?
That's a good question. There's definitely been some studies that have looked at, um, for example, they call them ice stupas. And so how can they essentially grow artificial glaciers in these high mountain areas such that the communities can have this fresh water in the end of the summer, um, replacing sort of what the glaciers provide naturally. Um, in Central Europe, there have also been efforts where they go out and they essentially put these white blankets. They're really textiles, geotextiles, but you're essentially taking a white blanket and you're putting it over the glacier in order to keep the albedo, the amount of sunlight that's reflected from the surface, really high. And that can also prevent some of the glacier losses. Um, because the glaciers move, those textiles typically get ripped up over time, and so it can be really expensive to replace. It's also unclear from an environmental perspective, when you're adding a lot of materials to a system that then get shredded up, how do you deal with removing those materials later? But there are various strategies that people are looking into to try to preserve the glaciers, or in some efforts to sort of build an artificial glacier.
Uh, One thing we talked about before we came on the air, and um, it's not really addressed in your presentation, but it is an effect for glacier loss. Is glaciers, of course, made of water, mostly have a mass, have weight, and so when you remove that mass and weight from underlying rock, what does that do to the overall geological structure of things like, I guess, places like Alaska and Greenland?
Yeah, it's a really fascinating process. It's called the glacial isostatic adjustment. And so when you remove that weight that's really pushing down on the Earth's surface, what happens is the Earth rebounds a bit. So you can actually see an increase in elevation in the area where the glacier used to be. And this process happens over very slow time periods. So, for example, if we think about the Laurentide ice sheet that used to cover a large section of North America, right, we still have that glacial isostatic adjustment effect that's occurring today. And when we model this in the future, there are solid Earth models that actually incorporate this process to think about how much elevation change will happen due to the loss of those glaciers and the removal of that weight that used to be holding down the land. And it can be a very important aspect of regional sea level rise projections. So what's really happening on a very local scale.
And are we talking about millimeters, feet, inches? I mean,
Yeah,
over time?
most of what we're talking about when we're talking about relative sea level rise is more on the millimeter to inches level. Um, feet is when we think about feet of sea level rise, that's really a lot.
I was talking about the geological bounce back, the
Yeah,
change in.
it's still it's a fraction of those changes. Yeah, so it's not if we have a foot of sea level rise that adjustment isn't going to be able to raise the Earth by a foot, right? It'll be a much smaller fraction, unfortunately.
So, to what degree remote sensing helps your research as far as using space-based technology?
Yeah, remote sensing is critical. And so, you know, you see, I mentioned NASA here, as well as some of our other supporters. And really, the new satellite missions, the Landsat satellite mission that's been going on since the 70s, they just provide really unbelievable images of how the glaciers are changing. And a lot of the newer satellites that come out, they not only show us visually how the glaciers are retreating over time, but they show us those elevation changes, how the surface of the glacier is changing such that we can compute the mass change. There's a lot of people, we had questions about how fast these glaciers are moving. And what we can do is we can use these repeat satellite observations, and we can actually track how quickly the glaciers are moving. And so that helps us understand how the glaciers are slowing down or speeding up at different times. And really, as we get more and more satellite observations, we have more information to be able to calibrate and validate our models, which is incredibly valuable.
So, if the average family wants to go on a summer jaunt to visit a glacier, where would they go?
It depends where you are.
Well,
And
just
I'd
in the
say,
United States, I guess, traveling somewhere.
yeah, in the United States, Glacier National Park still has several glaciers. They're definitely on the smaller end of the spectrum, but they are still up there. And so that would be one place that you could go visit. In the Pacific Northwest, Mount Rainier, for example, there are a number of glaciers up there that are fairly accessible. And beyond that, it's really getting up into southeastern Alaska has some of pretty accessible glaciers, especially around Juneau, for example. Or if you're fortunate enough to be able to go on a cruise, then you can see a lot of different glaciers from fjords, for example.
You in Scandinavia, you're talking about.
That would be in southeastern Alaska, but
Oh,
yes,
southeastern
in
Alaska. Okay.
Scandinavia there are lots of fjords with glaciers as well.
Hmm.
Yeah.
Fascinating. And so, tell us what your plans are for your future research in the last few minutes we have together.
Sure. Yeah, we're working on a variety of things, and I should say that a lot of this work is supported by PhD students who are working to get their PhD as well, and master students and undergraduate students, which is really exciting. Some of the things we're working on is, as I mentioned, there are all of these new remote sensing products, and so we're always looking to take those new data sets and incorporate them to improve our models. One of the projects from the National Science Foundation that we're working on is looking at the impact of extreme heat waves and wildfires and how that can affect glacier changes in Alaska. And then the National Academies project that I mentioned is really focusing on improving regional sea level rise projections and thinking about how we can support adaptation strategies in response to that sea level rise. So those are some of the whether it's looking at specific processes or going all the way to the adaptation, a lot of different and exciting areas of research that we're pursuing.
Wow. Well, thank you. Our hour has evaporated together very quickly. That was fascinating, and thank you, Dr. Rounce, and for your expertise. And I hope in your travels, if you're coming through Cartersville, you will come and visit our wonderful Science Museum. And also want to thank our sponsor, Century Bank of Cartersville, for their support for this program. And thanks to all of you out there in the virtual audience in tuning in. And remind you that this is a recorded program, and so you can find it It'll be live on our Facebook page next week. You can find this program has been recorded. And thank you so much for being with us today. Thank you.
Thanks for having me.